Hello everyone, this video covers section 8.1, confidence intervals for mu. In this chapter, the setup is going to be very similar to chapter 7, where we're going to talk about mu first, then p, and then sigma squared. So 8.1 is going to be for mu when we use z, then 8.2 when we use t, then 8.3 uses z, and remember 8.4 is going to use chi-squared, just like we did in chapter 7. Now, hypothesis testing is the last thing we're going to do in terms of topics. Like the rest of the class, except for two sections in chapter 10, have to do with hypothesis testing. So it's going to be the same story over and over and over. So this is the main idea. Somebody is going to claim something, so there is always a claim. So H0 is going to be the claim. So your job is pretty much to try to prove the claim wrong, and you're going to have three different alternatives. This is called a one-tail test, and this one is going to be called a two-tails test. Okay. When it's a one-tail test, we're going to use alpha, the exact same alpha since chapter 6. And if it is two tails, we're going to do alpha over 2, just like you did in chapter 7, where alpha was always divided by 2. So the part that is new, completely new right now, is step 1, because you have never seen something like this. All right, again, so this is how it's going to work. Somebody's going to claim something, and then you're going to use either this one, or this one. Well, how do you decide that? Well, let's say that your mom says she's going to give you $40. She says she's going to give you $40, and then she gives you 200. Are you going to complain? And the answer is no. However, if your mom claims, so that's a claim, she's going to give you 40, but she only gives you 20, then more likely you will complain. So in that particular case, the claim is going to be that she gives you 40. So this is also going to be the claim with the equal sign. Based on the information you have, since this is less than what she claimed, then you're going to pick this one. So pretty much the way you look at this is this to my advantage or not? If it's not to your advantage, then you pick the inequality that goes against what you want. The only one that is a little tricky is the one that is two tails, because that means too much is a problem and too little is a problem. So sometimes the question will say exactly, but it doesn't have to mention the word to be two tails. If you have a two tails question from chapter A, it will probably tell you in parentheses that is two tails. But for example, one case where something could be two tails is if you are a nurse, okay, if you have a patient, if you're given too much medicine, that's a problem because it may die of overdose. And you're given too little, it may be a problem because it may have pain. So therefore, in this case, it's either equal or not equal. So then this will be the two tails. All right, once you figure out step 1, which is the part that is new, then you can go to the other steps. But you have to be sure that step 1 is correct. Otherwise, you're going to do the wrong thing after that. Now, once you do that, step 2 is going to be to find C star. This is actually called the test statistic. And this formula and this one are the same. This is actually the exact same formula from section 6.3. So this is the formula from section 6.3, the central limit theorem. The only difference is that we put a star in here, and you'll see why as we go on. But this is essentially the same formula from section 6.3. So therefore, this is not new. The only part that is new is this. Now, there are two methods to do this, and yes, you need to know the two methods. The first method is called rejection region, method, which from now on we're just going to call it RR. And the second one is called the p-value. And like you will see right now, this is not really new. You have done this before. So the rejection region is going to be either a z of alpha, minus z of alpha, or plus or minus z of alpha over 2. Remember, you already have these values. This is the value 1.96, 2.58, 1.64, and so forth, and 2.33. Actually, it's only 4 of them. Okay. Now, how do you know which one to pick? Well, that depends on the alternative you have. So you have this one. I'm going to go with this. This is going to give you this one, and if it is 2 tails, it's going to give you this. So that's for the rejection region. What about the p-value? Well, for the p-value, you also need 3 cases. The first one will be this. The p-value will be equal to the probability that z is greater than z star, or the p-value is equal to the probability that z is less than z star, or the p-value is twice the probability that z is greater than the absolute value of z star. Again, this will go with this, this will go with this, this will go with this. By the way, in case you haven't noticed, this is also not new. This is exactly what you had to do in section 6.1. So this is a straight question from 6.1, except that now we have the star. Actually, the p-value is always going to be the green area that we talked about before. So the p-value is going to be the green area, and in this case it's just multiplied by 2. So therefore this part is not new. So you already know how to do this. Now the last step is where you have to do the conclusion and the summary. You will have 2 conclusions all the time. You either reject HO, or the other conclusion is fail to reject HO, which from now on I'm just going to write FTR, fail to reject. Now, this is very important because this is the whole point of the problem, that you reject, fail to reject, and then you have to explain. Now, let's go back to the beginning so to see why this is very important. Okay. So if you reject this, which is the claim, then automatically the alternative is true, but the opposite is not correct. And this means by opposite, if you fail to reject this, it doesn't make it true. It just means that you don't have enough evidence to reject it, but it doesn't mean this is true. This is actually based on the judicial system. So somebody, remember, is innocent until proven guilty. So if the person is proven guilty, then the person is therefore guilty because you prove it to be guilty. Now, if you cannot prove the person to be guilty, then you have to let the person go, saying that he's innocent. But does that really mean that the person is innocent? And the answer is no. You just couldn't prove that the person was guilty. So for the rest of the class, we're going to assume that this is true, and then your job is to pretty much reject it. And if you reject it, that means this is true. But if you cannot reject it, which means fail to reject, that just means you don't have enough proof to reject it, but it doesn't imply that this is true. Actually, look to this note, and this is what we're going to base it on to. If you want to support a claim, then you state it as the alternative. Because remember, if you reject HO, then this is going to be true. And if you want to disprove a claim, then you state it as the HO, because then the alternative is going to be true. Let's do a couple of examples so you can see a connection to this. Okay, let's do an example. this particular example says the following: the company ABC produces car batteries, and the CEO of the company claims that the batteries last at least 5 years. Okay, so that's the claim. Then a group gets a sample of 49, so that means N is 49. The sample has a mean of 4.3 years and the standard deviation of 1.6 years. So is there enough evidence to support the claim? By the way, this is how you know you had to do hypothesis testing. The question is always going to say, is there enough evidence to support the claim? And you need to always use alpha, because you're going to need alpha for the rejection region and for the p-value. All right, so what is the actual step one or the claim? The CEO is claiming that the average battery lasts 5 years. Actually, he or she is claiming that it's more than 5 years. But based on the sample, 4.3 is less than what the person is claiming. So therefore, you are suspecting that it should be less than 5. You are not trying to prove that it's 4.3. You're just trying to disprove the claim that is 5 or more. So therefore, the alternative should be less. And remember, from here, this is going to determine the rest of the problem. Okay, now, step 2, need to find C star, or the test statistic. Remember, this is equals to the square root of n, x bar, minus mu divided by sigma. So we plug in the values. This is the square root of 49 times 4.3 minus 5. Everything divided by 1.6, and this is around negative 3.1. Which, remember, these values, you knew this from section 6.3. All right, so now let's go to step 3. Remember that there is 2 methods to do this, and yes, you need to do the 2 methods. So the first method is called the rejection region method. This will be the first step. So we need to find the rejection region. Now, since this is less, that means the rejection region is going to be on the left side, which means it's going to be negative. So therefore, the rejection region is going to be minus z of 0.05. Why? Because alpha is 0.05. And since this is only a 1 tail, not 2, only 1 tail, then alpha is not divided by 2. Then if you look to the values that we use in chapter 7, like hundreds of times, this is just minus 1.64 or 1.65. Then you are required to draw the rejection region. So you have minus 1.64 here, and this part is the rejection region. This is going to the left side because this is pointing to the left side. So that's another way to look at that. So therefore, this is the rejection region, and this one is the fail to reject, HO. To decide to reject or fail to reject is very, very, very simple. What is the value for Z star? Z star is negative 3.1. Is 3.1 in here or is 3.1 in here? Well, clearly 3.1 is right here, minus 3.1, which is in the rejection region. So therefore, the conclusion should be obvious. Step 4 is reject HO, which means the mu is less than 5. Now the explanation will be that there is enough evidence to show that batteries don't last more than 5 years. there are many ways in which you can explain this. You can also say there is not enough evidence to support the claim that batteries last at least 5 years. So multiple ways to say the same thing. What you prove is that this has to be true. Remember, you rejected this, so that implies that this is true. So what you just prove is that the average life of batteries is less than 5 years, which is the opposite of what the CEO was claiming. The CEO was claiming that batteries last more than 5 years. All right, so you can see this is straightforward. All right, let me go through the whole thing again, because this is what you're gonna do in the rest of the chapter and actually the rest of the class. So first, you need to start with the claim. So this is the claim. The most important thing is to see the alternative. So this could be greater, this could be less, or not equal. In this case, this is less because the sample is less than what the person is claiming. Then remember, this is the same formula from 6.3. The rejection region, which is determined by step 1, is the same thing from 6.1. And then you have to draw the rejection region. If you are in this part, it will be rejected. If it is in this part, it will be failed to reject. For example, if this was negative 1.1, the negative 1.1 is here, so the conclusion will be failed to reject instead of reject. Remember that there is 2 methods to do this, and the 2 methods have to give you exactly the same conclusion. So let's try now the p-value method. All right, so for the p-value method, step 1 and step 2 are exactly the same. So then step 3, the p-value is going to be the probability that C is less than C star, which is equals to the probability that Z is less than negative 3.1. Remember that the only reason why we're using less is because the alternative is mu is less than 5. Now, this is exactly what you did in 6.1. Remember in 6.1, you have 0, negative 3.1 is here. So the area that you want is the green area. And remember, to find the green area, you can use the table or the calculator. You use the table, you find first the yellow area. Remember, this is what comes from the table. And then you do 1 minus the yellow area. So then, if we look to the table, this is 0.9904. So therefore, this will be 1 minus 0.9904, which is equals to 0.0096. Okay. Now, how do we use the p-value to determine whether to accept or reject? There is a rule which is in the formula sheet too. So this is the decision criterion, and you're going to use this the rest of the class. So this is how you decide. If the p-value is less than or equals to alpha, then you reject. And if the p-value is greater than alpha, then it will be failed to reject HO. So therefore, that's the last thing you have to do. So for step 4, the p-value we found was 0.0096. The value for alpha was 0.05. Make sure you use the same number of decimals so you can compare. So add 2 decimals here. So this is 500, this is 96. Clearly this is less. Because of this rule, then you have to reject, which should be not surprising because that's what we got with the last method. The 2 methods have to give you the exact same conclusion, and you don't have to explain this twice. All right, you didn't get the last problem. This is the chance to redeem your sins, so let's try this again. All right, so in this problem, Blue Bull claims that the amount of sugar is at most 50 grams. So therefore, the claim, which which is step 1, is that the amount of sugar is at most 50. Okay? But if you take a sample of 90 drinks, that means N is 90, X bar was 55, which is more than what Blue Bull is claiming. So therefore, the alternative should be greater than what he's claiming. Why? Because this number is bigger than what the company is claiming. You also have the following information, that the standard deviation is 5 and the alpha is 0.025. Alpha always has to be given, and if it's not given, then alpha is equals to 0.05 by default. So if it is not given, just use 0.05. All right, so then step 2, to find C star, which is equals to the square root of 90 times X bar, which is 55, minus 50, everything divided by 5, which is around 9.49. All right, so then step 3, you need to find the rejection region. Step 3 is always the rejection region. In this case, it's going to be Z of alpha, the positive sign. Why? Because this is greater, so that means you're going to the right side. The value for alpha is 0.025, so the rejection region will be 0.025, which is equals to 1.96. All right, so then draw the rejection region. Always put 0 for reference. 1.96 is somewhere here. So this will be the rejection region, and this will be the fail to reject HO. Now the value for Z star is 9.49, which is clearly in the rejection region. So therefore the conclusion is going to be reject HO, and the explanation is that there is not enough evidence to support Blue Bull's claim that the amount of sugar is at most the amount of sugar is at most 50 grams. Okay. Or you can also say there is enough evidence to show that the amount of sugar is more than 50 grams. Either way is fine. All right, so remember, once you do the rejection region method, which was this, we can use the second method is the p-value. So let's try that now. So remember, for the p-value, so p-value method, step 1 and step 2 are exactly the same. That won't change. So therefore, step 3, the p-value is going to be the probability that Z is greater than C star. Again, we're using greater here because the alternative was greater. The only time you have to be careful is when it's 2 tails. But if it is 1 tail, this is less, this is less. If it's greater, this is greater. Here we have, therefore this is the probability that Z is greater than 9.49. Remember, the green value is technically the p-value is technically the green area all the time. So you want 9.49. So this is the area you want. Now, we did an example like this before, where if you look to the table, the Z table, the biggest value you have on the table, remember, was 3.59. And after that, the area keeps just repeating, which means nothing changes. If we use the table, the value for that is equals to 0.999A, which is the last value on the table. And this is also the yellow area. So therefore, to find the p-value, this will be 1 minus 0.999A, which is around 0.0002. Again, this is not the exact value, this is an approximation, but this is enough for the purposes of what we're trying to do. If you use the calculator, it will give you the exact value, and for that you will need to use normal CDF 9.49 and 1000 with the upper bound. The value for this is so small that people can get a little confused. So it's for something like this, and by that I mean if the number is more than 3.59, it's better to use this value, because after that, all you have to do is compare this. So remember, the p-value is 0.0002, alpha is 0.025, so you just add two zeros. Clearly this is less, and that implies to reject HO. Now, if we use the value you will get from here, you will end up with like 20 zeros, which clearly is less than this one. So it's up to you, but if the number is more than 3.5, if the Z star is more than 3.5, you should just use this value and it will work every single time. If you notice in the last two examples, alpha was either 0.05 or 0.025, which means we were like 95 or 90% confident in some sense that this is true. So we're going to make mistakes or errors. So there are two types of errors that can happen. So for that, let's say that you have let's do a table where you have HO is actually either true or is actually false. Okay, that will be the first case. And then here we're gonna have reject HO or fail to reject HO. So there are four things that can happen, and two of them would be mistakes. So this is what I mean. This will be the correct case. This will be correct too, when you reject the claim and you were correct, or when you fail to reject and you were correct also. But then here you have a type 1 error, and it will be a type 2 error. So a type 1 error is going to happen when you reject HO when it's actually true. For example, the very first example we did, remember the claim was that the batteries last 5 years, and our alternative was that no, it has to be less than 5 years, and we actually rejected this. That was the conclusion, we rejected this. Let's say that we had made a mistake and this was actually true, then we're going to make a type 1 error. That's what it means. Okay? Sometimes this is just called a false positive. Okay? Now, the probability that you're going to make a type 1 error is equals to alpha. So therefore, the smaller the alpha, the smaller the probability that you make a type 1 error. Now, a type 2 error happens when you accept, and remember, accept technically means fail to reject HO when it's actually false. And this is sometimes it's called a false negative. Now, the probability of a type 2 error is called beta. We're not going to go much into this, but beta is actually not that easy to compute. Well, this one is just given to you. You already know what's the probability of making a type 1 error is by selecting the value of alpha, which is just given to you. Now, one thing that is very important is alpha plus beta is not equals to 1, which means 1 is not the complement of the other. Or, in other words, a type 1 error and type 2 errors are not the opposite of each other. Okay? Why is that important? Because if you make this pretty small, then this one will become big, and if you make this big, this one may become. You make this one small, this may become big. Okay. So for now, the important thing is that you identify the two types of error. So type 1 is when you reject something that was actually true, and type 2 is when you fail to reject something that you should have rejected pretty much. Okay? Now, there is something else called the power of the test, but we're not going to deal with this in this class. This is a little more advanced, but the power of the test is 1 minus beta. And as I mentioned a little bit earlier, to find beta is not that easy. We're not going to do that in the class. So therefore, you can just, for now, go with the idea that the power of the test is 1 minus beta. By the way, even though we did this in section 8.1, this is not unique to 8.1. This will be the case for 8.1, 8.2, 8.3, actually everything in chapter 9 and even in chapter 10. So you can make a type 1 error in any section in chapter 8, 9, or 10. So it's not unique just to section 8.1. All right.